Hello and welcome to another video. Today we will be learning about rational functions and zeros. As you remember from one of our previous lessons, a rational function is going to be a function that is a ratio of two polynomial functions divided by each other. Here we have an example of a linear polynomial as my numerator, 2x minus 3, and then I have a quadratic polynomial in the denominator of x squared minus 4x minus 45. This is what all rational functions look like. Back in 1.5, we did talk about polynomial inequalities, and then we can reuse some of those concepts to help us understand rational functions and do inequalities for rational functions as well. Before we get started, there are two important traits about rational functions that are always going to be true. The first one has to do with zeros. And it's listed right here. It says f of x has zeros when g of x is equal to 0. So if you have the function f of x equals g of x divided by g of x, the numerator will always give me the zeros. So we can make a note here. The zeros will be given by the numerator. If you look at number 2, it says f is undefined when h of x is equal to 0. So when the denominator is 0, I will get an undefined. So undefined values will be given by the denominator. This will be important as we do our sign chart and look at the inequalities. This is different from polynomials because in polynomials we only had zeros. We plotted the zeros on the sign chart and then we use that information to find our answer. Now, when we're solving rational inequalities, we care about both the zeros and the undefined values. So we care about when the numerator is 0, and then we care about when the denominator is 0. So the sign chart might have a few more numbers than before, but same concept. Some of these steps might look familiar to y'all because we did a few of them exactly the same when we were doing the inequalities for polynomials. Step number 1 says make sure you have the inequality that has 0 on the other side. So that one is the same. Always look for 0 either on the left or the right side, it doesn't matter. Step number 2 says make sure that f of x equals g of x over h of x. So we're basically looking for a single fraction. If you have multiple fractions, you might be able to combine them into a single one and then use the steps. But for today, everything will be given to you as a single fraction, but just keep that in mind for the future. Step number 3 said g of x equal to 0 and h of x equal to 0 to find the values to include on the sign chart. Again, it will be easier, of course, when we are given the factored ones, but if they're not given to you, factor if necessary. Step number 4, we're going to create the sign chart with the values from step 3. So when g of x is equal to 0 and when h of x is equal to 0. Be careful to mark where the h of x is equal to 0 so that we never include those values in our solution. So these are going to be the undefined values that I talked about earlier. Then you're going to test the values in each of the intervals to see if the intervals are positive or negative. After that, we're going to interpret the chart to answer the given inequality from the problem, just like we did before. Please make a note to be sure to write your answer in interval notation and think about the endpoint. So remember, the endpoints could be included with brackets or they could be excluded with the parentheses. Hopefully, everything will make more sense with an actual example. So if we look at example number 1, step number 1 says to make sure you have an inequality with 0 on the other side, which we do have here. Step number 2 says make sure you have a single rational fraction, which again we have here. Step number 3 says to set g of x and h of x equal to 0, and then find the values to include on the sign chart. Make sure to factor. In this case, it's already factored. So I'm going to go here and make a note about my zeros and then my undefined terms. So again, my zeros will come from the numerator. I only have x minus 2. Set x minus 2 equal to 0. Add 2 to both sides. and then I get x equals 2. So I have 1 0 at x equals 2, so that's what I'm going to write here, 0 at x equals 2. If I look at the denominator, I have 2 parentheses with x's on them, so that means I do have 2 undefined terms. So I'm going to do x plus 6 equals 0 and x minus 3 equals 0, solve them each one individually. And then I get x equals -6 for the first one. And then I get x equals +3 for the second one. Next step on my steps that they gave me, I'm going to create a sign chart using all of the values from the zeros and the undefined terms. So in this case, I have 3 of them. I do put them in order from smallest to largest, or least to greatest. So I'm going to start with -6, then 2, and then 3. After that, I'm going to test the values on each interval to see if the values on the interval are positive or negative. So I'm going to pick a number on the first interval here. So I need to pick a number less than -6. No, actually, before I do that, I'm going to mark the ones that came from the undefined term. So these two can never be included as part of my answer. So just keep that in mind. Now I'm going to plug in my -7. So I'm just going to write all the steps here. -7 minus 2 over -7 plus 6 over -7 minus 3. Again, you don't have to do this all the way. I'm just doing it to show you until we're comfortable, and then hopefully we can go into the shortcuts. So -7 minus 2 will give me a negative. -7 plus 6 will give me a negative. And then -7 minus 3 will give me a negative. When I try to simplify this, I can do this multiple ways. I can cancel out a negative from the top and the bottom, just giving me a negative. So the first interval is negative. For the next one, I am going to do the same thing. I'm just going to do it a little bit quicker now that we know what we're doing. So a number between -6 and +2 will be 0. 0 minus 2 will give me a negative on the numerator. 0 plus 6 will give me a positive, and then 0 minus 3 will give me a negative. I can do the same thing, cancel the two negatives, leaving me just a positive. So I know the second interval is positive. This one I'm forced to pick a decimal because I have to pick a number bigger than 2 but less than 3. 2.5 is probably the best one that makes you feel the most comfortable. So again, 2.5 minus 2 will give me a positive. 2.5 plus 6 will give me a positive. And then 2.5 minus 3 will give me a negative. Think of these two canceling it out, leaving me a negative. You want to think of it that way. For the last one, I am going to pick a number larger than 3. So I'm just going to do 5. 5 minus 2 will give me a positive. 5 plus 6 will give me a positive. And then 5 minus 3 will give me a positive. Again, all of them are positive, so my last interval should be positive. Now I'm going to interpret the sign chart to answer the inequality that was given to me. So I know that I'm looking for numbers that are larger than 0 or greater than or equal to 0. So I'm going to be looking at my positive interval. So I have 2 of them, one highlighted here in red, and the other one is highlighted here in red as well. So the first one starts at -6. Don't forget -6 has to be included because it was one of the undefined terms or undefined values. And then it stops at 2. 2 can be included. Don't forget this is going to be a 0, a root, a solution, an x-intercept. When x is 2, my y value will be 0. After that, I'm going to go into the second interval, which starts after 3 or at 3 all the way to infinity, and then this will be my first answer. Let's look at example number 2. For example number 2, I do have to factor because I do have a single fraction. I do have a 0 by itself, but I don't have the factor, so I need to factor. I have a difference of 2 perfect squares, so that's going to be x plus 2 times x minus 2. For the bottom one, again, I'm looking for two numbers that multiply will give me 25, but need to add up to -10, so it's -5 and -5. So x minus 5 times x minus 5 are my factors. After that, I'm gonna solve for my zeros and my undefined values. So for the zeros, I have two of them. So when I set them equal to 0, I get x equals 2 and x equals -2. And then for my undefined values, I do have the same one. I only need to list it once, which is x equals 5. After that, I'm going to create my sign chart with 3 different numbers. The smallest one is going to be -2. The next one is going to be 2. And the largest one is going to be 5. 5 is the only one that should be excluded because it came from my undefined value. I am going to do the same thing as before. I am going to pick a number less than -2, like -3. -3 plus 2 will give me a negative. -3 minus 2 will give me a negative. And then for the bottom one, -3 minus 5, negative, -3 minus 5, negative again. So these two will become positive when I multiply my numerators. These two will become positive when I multiply my denominators. So the first interval is going to be positive. Next, I'm going to pick a number between -2 and +2, like 0. 0 plus 2 will give me a positive. 0 minus 2 will give me a negative. 0 minus 5 will give me a negative. And then 0 minus 5 will give me a negative again. Again, when I look at the denominator, they're both negative, so I can make them positive. And then I have a negative left on the top. So my whole interval for that one is negative. I'm going to continue onto the intervals, and the next one I have to pick a number between 2 and 5. So I'm going to pick 3. 3 plus 2 is positive. 3 minus 2 is positive. 3 minus 5 is negative, and then 3 minus 5 is also negative. So these two become positive. Everything is positive. My next interval will be positive. For the last one, I need to pick a number greater than 5, like 7. 7 plus 2 is positive. 7 minus 2 is positive. 7 minus 5 is positive, and then 7 minus 5 again is positive. So everything is positive. My answer is positive for that interval. Now I need to analyze what they want. They want less than 0. So I'm looking at the negative intervals. I only have one negative interval, which goes from -2 to +2. Again, it's less than, so all the endpoints should be excluded no matter what. A few more examples. Example number 3. I don't have a 0 because of the numerator will never be 0. And then on the denominator, I do have an undefined value. So set x minus 3 equal to 0, I get x equals 3. After that, I'm going to draw my number line. When I draw this number line, I only have one number, which is 3. So I need to plug in a number less than 3, like 0. So 2 over 0 minus 3, which in this case will be -2/3. So I know that my answer for that interval is negative. For the other one, I'm going to pick a number bigger than 3, like 4. So the top is always positive. And then 4 minus 3 is also going to be positive, giving me a positive interval. After that, I'm going to circle that because that one is an undefined value. It will never be included as part of our answer. But on this problem, it doesn't matter because I want the numbers to be greater than 0. So my final answer will be 3 all the way to infinity. Okay, let's look at example number 4. We do have a single fraction. We do have 0 by itself. I can factor using the greatest common factor for the numerator. So it'll be 4 times x plus 2. And then the denominator is already kind of factored out. So I'm going to make a note that I do have one 0 at x equals -2. And then I have an undefined value at x equals -5. So when I draw my sign chart, I should have two numbers. The first one is going to be -5, and then the next one is going to be -2, coming from our zeros and undefined values. I'm going to pick a number less than -5, like -6, and I'm going to plug it in into here and here. These four will always be positive, and then -6 plus 2 is going to be negative, and then -6 plus 5 is also going to be negative. So these negatives cancel out, giving me a positive for my first part of the interval. For the next part of the interval, I'm going to pick a number between -5 and -2, like -3. So again, 4 is always positive. -3 plus 2 is going to be negative. And then for the bottom one, -3 plus 5 is going to be positive, giving me a final answer of a negative interval for that one. For the last one, I'm going to pick a number greater than -2, like 0. So positive for the 4, 0 plus 2 is positive, and then 0 plus 5 is also positive. All of them are positive, meaning my last interval will also be positive. After that, I'm going to put my undefined value on here because this one should be excluded no matter what. And now I'm ready to look at my answer. I want it to be less than or equal to 0, meaning I'm looking at my negative intervals. Again, I only have one right here. When I start writing my interval, I start at -5. Again, that number came from my undefined value, so it should always be excluded no matter what. And then I end my interval at -2 with a bracket. So that should be the answer for example number 4. Example number 5, I do have a single fraction. I do have 0 on the other side. So I'm going to solve for my zeros. And then I'm going to solve for my undefined values. So I have two zeros on here. The first one will be x equals +1. The second one at x equals -2. And then for the undefined values, the one that came from the denominator, I only have x equals 2. So I'm going to start drawing my sign chart using the three numbers that I just found. So the smallest one is going to be -2, and then 1, and then 2. Since 2 came from the denominator, that one has to be excluded no matter what. After that, I'm going to start plugging in my numbers from my intervals to get the sign. So a number less than -2, like -3. -3 minus 1 will give me a negative. -3 plus 2 will give me a negative, but then I'm squaring it, giving me a positive. And then at the bottom, -3 minus 2 will also give me a negative. Well, all I have is a negative divided by a negative, which will make it positive, meaning my first interval is going to be positive. For the second one, I pick a number between -2 and 0, like between -2 and 1, sorry, like 0. So 0 minus 1 is negative. 0 plus 2 is positive. Squared is still positive. And then 0 minus 2 is negative. So these two negatives cancel out, giving me a positive interval for this one as well. For the next one, I'm going to pick a number between 1 and 2, like 1.5. So 1.5 minus 1 is going to be a positive. This one is squared, so it's positive as well. And then 1.5 minus 2 will give me a negative, giving me a final answer of a negative interval. For the last one, I'm going to pick a number larger than 2, like 3. 3 minus 1 is positive. 3 plus 2 is 5, positive. I squared is still positive. And then 3 minus 2 is also positive. So everything is positive on this one. So my final answer for this interval is going to be positive. Now I'm looking for greater than 0. So I can look at my intervals and see how many I have. I have two here that are together, and then I have another one here that is separate. Here I have to ask myself, do I have to stop at -2, or can I continue my interval all the way to 1? Well, -2 is part of my answer because of that equal to. So I don't actually have to stop at -2. I can go all the way from -infinity to +1 and include it. And then after that, I do have to stop because I need to skip all of these values and then start at 2 again with a parenthesis because again is one of my undefined value all the way to infinity. Okay, and then that's my answer for this one. For example 6, again, I do have a single fraction. I do have 0 on the other side. I don't have any zeros for this one, so I'm just going to write no zeros, but I do have undefined value. I have one of them, which is here, x equals +1. So when I draw my sign chart, I should only have a 1 there. I'm going to pick a number less than 1, like 0. So a positive at the top, and then 0 minus 1 is a negative, but then when I square the negative, it turns into a positive. So I have a positive divided by a positive when I'm done simplifying. So this interval is positive. For the second part, I'm going to plug in a number larger than 1, like 2. Again, numerator is always +1, and then 2 minus 1 is positive. I squared it, it's still a positive. A positive divided by a positive, of course, is a positive. So I'm looking for numbers less than or equal to 0. Don't forget 1 is an undefined value, so I'm going to need to skip it regardless. And then I notice that to the left of 1 is positive, 1 is undefined, and to the right of 1 is positive. So I actually don't have a solution for this one, so I'm going to write no solution and be done with this problem since my values are always positive or undefined. The last example is asking you to do rational functions using a graph. We did this with polynomials, so it should be pretty easy. A is saying to find where f of x is less than or equal to 0. So I'm going to color code this a little bit, highlight my x-axis because that's what I'm looking at here. And I want to be below that pink line I just drew. I can see that on this part that I'm highlighting in green, I'm below that line, and then on this side that I'm highlighting in green, I'm also below that line. Since it says less than or equal to, my zeros need to be included as my answer, so I highlighted them for you. So for the first one, don't forget this is an undefined value, so it can never be included. So these are going to be your asymptotes. So I do start right after that value at -3, and then I stop at -1, include it. After that, the next time that I'm at the line or below the line is going to be at x equals 2. So I'm going to do 2, include it, and then go all the way to only 3, because that's my undefined value where it stops. As you can see, this green line will never cross this dashed line. Okay, for the second one, I'm looking for where f of x is greater than 0. So what I'm going to do is I'm going to highlight anything above the pink line. So I have this right here on purple on the left, this right here on purple on the right, and then I have this middle piece that I'm highlighting in the middle. Okay, for the left side, I do see that I have a left arrow, so I need to start at -infinity all the way to the dashed line, which is -3. After that, I must exclude the endpoint because it's greater than, so I start at -1 all the way to 2, and then from 3 all the way to infinity for the last part of the purple line. For the last one, I'm looking for f of x greater than or equal to 1, so I'm going to put this yellow line here, and all I care about is anything above that yellow line. Well, I can see that I have this purple line and this purple line. This one is below it, so that one is not going to be counted, so it's going to be kind of similar to B. For this one, I'm going to start at -infinity and stop at -3, and then union +3 all the way to infinity. I didn't want to put it in yellow because then you won't be able to see it. But hopefully everything makes sense today. Thank you for watching this video. Don't forget to like and subscribe, and see you next time.